Hello, my name is Denis Ashterev, and I've been working in a group of four on stock sentiment analysis project. One project estimates the correlation between tech sentiment of articles or stock price reviews with the real price fluctuation. Um, our implementation basically is divided into three main modules, and each module contributes to the execution of the other modules. So, to summarize, really basically, um, this is a real scenario diagram of our architecture. We have a data scraper module, which is supposed to extract and scrape data from the Now database. We have another module for data preprocessor. It extracts the financial sentiment based on given timestamp and prepares the results for the next module, which is the sentiment predictor. And the main purpose of sentiment predictor is uh, uh, to create the text sentiment and to use it um, and to use the text sentiment and the result from the previous step to estimate um, for each article whether there is a correlation between the actual sentiment of the price and the text, the meaning of this data per company. Every record is based on a data that is recorded per company, and we use the top 90 companies um, and following their indexes. Also, the sentiment predictor has additional steps for machine learning prediction that we will look into later. There is another idea. There was idea to use a MapReduce based on partitioning um, of the company to run in parallel the sentiment predictor and sentiment extraction for every company. But we didn't have the time to work further on it. Now, a little bit more about the sentiment predictor, the part that I was working on. I'm basically using the following structure as input. Um, this input comes from the previous step, the sentiment extraction of the financial data. And all of this data is having a timestamp, given sentiment value, which is 1, 0, or -1, and the corresponding text for the company stock price. For example, this input is based on the Apple 8K data with threshold 0.9. Then going into the code, the sentiment predictor, it for every single folder, we did one experiment having 3 folders with 3 separate thresholds. So for every threshold, I'm reading the file, extracting the data, and using um, um, using the corresponding data of the sentiment as field for verification and the review as field uh, for estimating the text sentiment. Basically here I run a code produced from TechBob library, which based on corpus of positive and negative words, each word has some positive or negative weight. it estimates the sentiment of the article. Then it does comparison between the actual sentiment and the sentiment that comes from the text. And I store all the results into an array. And later this array is used to calculate the correlation percentage between text sentiment and stock price sentiment. Um, we have I've created additional training modules using multilayer perceptron for classification and also big RAM support vector machine, or also mixed between unigram and big RAM support vector machines, dividing the data into 80% for training and 20% for testing. I wanted to find some correlation, some pattern that we can use to directly predict the sentiment uh, of a given article. So running the code, um, it starts estimating for every company the correlation percentage, the accuracy from the neural network, from the bigram SVM, or for the mixed unigram or bigram SVM. The chart here represents the relation between predicted sentiment and estimated sentiment. So we can see whenever the predicted goes up, there is some correlation, actually it's 50% correlation, that the estimated sentiment also goes up. This runs for every company, for every threshold parameter, and the output looks like the following. So for these 90 companies, we produce the output from estimated versus text sentiment, and I also produced the output for multi-layer perceptron, support vector machine, and unibigram layers support vector machines. Uh, One interesting fact is when we do the mean, the average of all these 90 companies, we can see that we have 78% of accuracy for in the case of correlation between actual versus predicted sentiment, uh, which in comparison with other uh, existing softwares is significantly good number. We also have for about 51% predict of accuracy using multilayer perceptron, almost 50 for support vector machines, which did not give us, it's like a beast coin. We are not able to determine exactly the sentiment based on the given data. Um, Basically, yeah, this is what we have. Thank you for the attention.